All right, here we go. Page 3 of this practice test. Number 14, find all values in radians for which the given statement is true. All values. All right, so not just in an interval like 0 to 2 pi, but all of them. All right, so, basically, for what angle is the tangent equal to a -1? Okay, and so this is going to occur, for tangent. This occurs in quadrant 2, and this occurs in quadrant 4. All right, and so typically we would cycle both of those by the period and then times n for infinite cycles. But here with tangent, having an every other quarter type of relationship, if I cycle 3 pi over 4 by pi one time, that's going to be 4 pi over 4, which is going to be 7 pi over 4. So with tangent, you can just do the first value, the first quadrant value that you get. In this case, this is our quad 2, and you can just cycle it by the period. So tangent is special in that way because it has that every other quadrant relationship. All right. Cosecant is, partnered with sine. So we're going to think about that. So sine is going to be positive in quad 1 and 2. And this is the reciprocal of, the reciprocal of this is 1 over root 2, which when rationalized is root 2 over 2. So that's over 4 angle. And so in quad 1, we are pi over 4. And in quad 2, we're 3 pi over 4. Okay, and so we have to account for both of those because sine doesn't have that every other relationship or like tangent. And then we have to cycle by the period, and the period for sine and cosecant is 2 pi. And then we do that, infinite times. And so that's letting n, n's an integer there. So, if it's 0, you get the pi over 4, or 3 pi over 4. If it's 1, you get a cycle. If you go negative, that gives you the negative angle, so on and so forth. All right, and cosine now. Cosine is negative in quads 2 and 3. So we're going to have to count for both of those because that's not like an every other relationship. And so we need to give this angle in quad 2 and 3. And this is a negative root 3 over 2. That's going to occur for cosine for a 30-degree angle, which is an over 6. And we just got to get those in the correct angle, the correct quadrant. And so in quad 2, that's your 5 pi over 6. Your 30-degree angle in quad 2, you'd have 5 of those to get you to 150, which is 30 degrees away from 180. Let's cycle that. And then let's cruise into quad 3. So we're going to go 30 degrees past 180, which is 210. And there's 7 30-degree angles in 210. So that's 7 pi over 6. And there you go. All right, so we went through all of these parametrics just for practice, but this is not going to be on the test. It was fun to go through, and you learned a little something, but we are going to just focus on the Mickey Funhouse. So here we go. This video won't be that long. All right, here's our Mickey Fun Wheel at Disneyland, California Adventure. All right, so here we go. Let's draw this thing. So we have a Ferris wheel, circular. Diameter, ooh, they're trying to trick me. Diameter of 160, so I'm going to make sure I note that the radius is 80. Okay, so just put that in every direction here. I'll just, go like that. Okay, those are all feet. Feet. All right, the bottom is 10 feet underground. Okay, that's a little different. So we're underground. All right, so instead of this 80 here, I'm going to think of this as 70, and this is going to be -10. Okay, sort of treating this as the origin right here. So there's our little bucket. Well, assuming we start at the bottom, let's see. Bottom is 10 feet underground, yes. Completes 3 revolutions in a 9-minute period. 3 revs per 9 minutes. Moving at constant speed, that's good. Write a sinusoidal, that's sine or cosine. Using a phase shift, without using a phase shift, okay, that's good. Which describes the height. All right, so we're doing a height. The y values, and assume I enter the wheel at the bottom. Okay, so we do enter the wheel at the bottom. and we're traveling counterclockwise, so opposite the way the clock would go. Okay, so let's put this in a chart here. We got times, and we got vertical positions. Okay, so this is sinusoidal. So we're going to need a start, a finish, a halfway, quarter. There you go. So you're going to need these 5 values. Okay, so let's think about our time. Well, 3 divides into 9, so that's great. Let's just take this down to 1 revolution. My goodness, for 3 minutes. Why would we not? 1 revolution for 3 minutes. So that's your period, you guys. So, we're going to go just like this. 3 minutes. Okay, so let's half it. Half of 3 is 3 over 2. Let's quarter it. 1/4 of 3 is 3 over 4. And let's do a 3/4 mark. So 3/4. 3 times 3 over 4 is 9 over 4. There's my times. And those are in minutes. And my height are in feet. Okay, so let's think about it. So we start the problem at the bottom. That's important. Where we start is important because what is this vertical height? Well, that's a vertical height of 10 feet underground. Counterclockwise is important. So we're going to go here, and at the quarter point, we're at, how high are we? We are at 70 feet. Okay, and at the halfway point, we're at 80 plus the 70, so that's going to be 150. Okay, so you got to count for this 10 underground. So just treat this like the, coordinate plane, and that's 0, 0. So this is a height above, ground of 150. Back to our 70 here. So this is a 70 feet above ground. And then 3, we're back at our starting point. And so we can write our sinusoidal for this and no phase shift, so that's nice. So it looks like, your midline here is 70. So this is low, midline, high, midline, low. That is negative cosine. So y equals negative cosine. Okay, that's our sinusoidal parent. All right, so, what is our amplitude? Amplitude is 1/2 max minus min. 1/2 max minus min. Add the opposite. That's 80. Okay, newsflash, everybody. Amplitude is going to be the same as the radius of your Ferris wheel. So there's a little tip for you. All right, and then so our period is 3, so we need this b value that comes before t. So I'll just go up here. Period is 3, so 2 pi over b had to equal 3. And what are we going to do here? Switch. And so it is going to be 2 pi over 3. B value is going to be 2 pi over 3. T for time. Okay. And then the last thing we have is we have a vertical shift here. And so to get that, we're going to just figure out that D value. And so we're going to figure out that D value, we're going to do 1/2 the max plus the min. Officially, this is how you do this vertical shift, this D value. And so this D value, I guess I can put equal marks here. Why not? This D value is going to be 1/2 of 140, which is 70. Okay, so let's tag that on the end. Another news flash, everybody. The vertical shift is the same as the midline that you see. I'm just giving some room here. Let's do y of t just to be really great. Negative 80 cosine 2 pi over 3 t plus our midline plus 70. The midline's the vertical shift. So little helpful hints for you there. All right, so there you go. That is a equation that will model your vertical height on Mickey's Fun Wheel. All right, guys, I hope this helps. Good luck studying. We will see you in class, and make it a good one.